Bismillahirrahmanirrahim. Today we will cover the fourth part of our chapter suspension. This is the last part of this chapter. First, I like to have a quick recap of all the three parts which we have studied, and then we will study the last part. The topic or the chapter we are studying is the suspension system of automotive technology. This is the main slide which we are following. We are through with this engine power developed up till the wheels. We have covered the brakes, and now we are talking about suspension system. So what is suspension system? With quick recap, suspension is the term given to the system of springs, shock absorbers, and linkages that connects a vehicle to its wheel. So it protects the vehicle itself and any cargo or luggage from damage and wear. So this is the general layout of the suspension system, the front portion of or front part of the suspension system and the rear suspension system of a vehicle. This is how it looked like. The purpose of the suspension system was smooth ride, accurate steering, responsive handling, sports for the weight of the vehicle, maintenance of acceptable tire wear. Then we have studied the suspension principle. Basically, wheels should be moving up, really up and down, and it supports the wheel and the body traverse or side to side wheel support or longitudinal front to back wheel support. Then we talked about the suspension principle and the some parts of the suspension system. And then we talk about the suspension design. So two very important design factors while designing a suspension system, we have to take into consideration, that is anti-squat and anti-dive. The function of the suspension system we have studied. Then we have talked about the frame construction or the chassis. The five types are the ladder, perimeter, space frame, subtype, and unit body construction. Then we have talked about the ladder frame, perimeter frame, space frame construction, subtype frames, and unit body construction. And then we talk about the bulkhead and the platform, the chassis of the system, then the track and the base. We have covered these terminologies. What is track and what is wheelbase? Then we have talked about the unsprung weight in our first chapter. Then in second part, we have covered the suspension type. Basically, there are two types, dependent and independent. Independent, we have Hotchkiss and four-link, and in independent, we have trailing arm suspension, short, long arm front suspension, MacPherson STRUT, trailing arm rear suspension, semi-trailing arm, and swing axle. So these independent and dependent suspension types with the figures. Then a few words about the dependent. Both wheels are dependent on each other. If one is felt, one wheel felt something, the same is transferred to the other wheel. And solid axle is used in dependent suspension system. In an independent, both wheels are independent of what is happening to the other wheel, generally. And then we have talked about the different things and the springs. Four types of springs generally used in the suspension: coil spring, leaf spring, air spring, or torsion bar or stabilization bar. Then we have talked about the coil spring, the coil diameter, number of coil, height of spring, and diameter of the steel that forms the spring. Then we have calculated this formula. Then we have talked about the leaf spring, which is used in the heavy vehicles, or previously it was used in light or middleweight vehicle, and how the leaf spring is mounted to the chassis or the frame or the body of the vehicle. Then we have talked about the torsion bars. Then a few words regarding the air spring, which is used in pneumatic air inside. Then we have talked about the steering knuckle, which houses or which is the main pivot point for the wheel and suspension system. And all the suspension is attached with your steering knuckle. This is your steering knuckle. spindle, and this is your steering knuckle, the upper control arm and the lower control arm, or in other case, we have this steering knuckle and the spindle, and we have this kingpin where we have the I-beam is attached. Then we have talked about the ball joints. The upper control arm and lower control arms are joined with the ball joints with the steering knuckle. Then we have talked about the components of the suspension system in the third parts. There are 7 parts: control arms, ball joints, strut rods, stabilization bars, shock absorber, strut assembly, and track bars. First was the control arms, which is the main part of the suspension system. It is attached to your steering knuckle. This is your steering knuckle, this is the spindle, and this is the upper control arm and lower control arm, and everything rests on these. And these control arms are joined with the steering knuckle with the help of this ball joint. Then we have talked about the load carrying ball joint and non-load carrying ball joint, or the follow ball joints. The upper one is the load carrying and lower one is the non-load carrying. In this condition, the upper one is non-load carrying and the lower one is the load carrying. Then we have talked about some other type in which the shock absorber assembly is mounted on the upper control arm. So the weight is on the upper ball. So that is the load carrying ball arrangement. The ball joint like this. The ball joint are 2 types basically designed: the compression loaded and tension loaded. Then we talked about the strut rod. The strut rod is used for maintaining. The purpose of the strut rod is to provide forward and backward support to the control arms. So it is very important. This is your strut rod, which is attached to your control arm with, on one side and other with the frame or the body of the vehicle. Then we talked about the bushing. It should be insulated. It should be having a shock absorber arrangement. Then we have talked about the stabilization bar, which is present in most of the car. And this is your stabilization bar, the stabilization bar link, the stabilizer bar bushing, this and stabilization bar. And same goes to the other side. And it helps the body to lean when the stabilizer bar is twisted. Stabilizer bar, the same. These are the few characteristics of the stabilization bar. Then we have talked about the shock absorber. The basic purpose of the shock absorber is do not support the weight of the vehicle, but the spring supports the weight of the vehicle. The shock absorber controls the action and reaction of that spring. Remember this thing. These are the few illustrated diagrams of the shock absorber, what is happening inside. Then we talked about the strut assembly, strut rod, and strut assembly. These are 2 different things. A strut is a sturdy shock absorber that is also a structural component of the suspension. A strut is a suspension link as well as a shock absorber. This is the strut assembly, and mostly used is the MACPHERSON strut assembly, which is attached to the steering knuckle on the instead of the upper control arm. We have this strut assembly. Same, the detailed diagram of the strut assembly. Then last one was the track rod or the panhead rod, which is used in the rear of the suspension of the vehicle. It is used to use on the rear axle to prevent side-to-side movement during cornering. So now coming towards the last part of the chapter, or this the 4th part of the suspension system. Now we talk about these specific few suspension systems which are used in a vehicle. First is the strut suspension. Strut suspension can be of several types. MACPHERSON strut includes the suspension springs that transfer the weight of the body to the wheel. A MACPHERSON strut is the main load-carrying suspension spring. We will see. This is like this. A MACPHERSON strut typically incorporates an upper and lower spring seat, a shock absorber mount, and dust cap and dust cover for the piston rod, and a bump stop. The upper mount secures the upper spring seat to the strut tower. The rubber bushing at the top of the strut absorbs vibration. In most applications, a bearing on the top of the front wheel strut allows it to rotate on a vertical steering axis without rubbing against the strut tower when the steering knuckle turns. The lower spring seat is attached to the strut casing. The piston rod dust cover is similar to the dust cover on the conventional shock absorber, and a bump stop at the top of the piston rod keeps the stirred from bottoming out during the suspension jounce. Let's see what we are this figure. Basically, these are the stirred retainer, the rod nut, the ball bearing, the bumper. Then we have this isolator, then we have this rubber bumper, the coil spring, the shock absorber, and this is the dust cover. This is the stirred shock assembly, oil, valve, and this is attached lower to the control arm. So these are the bushing which we are talking about. The most widely used front suspension system in the car is the MacPherson stirred type spring and shock absorber combo, pivots on a ball joint on a single lower arm. It physically twists the stirred and shock absorber housing to turn the wheel. So it is like this. The basic MacPherson stirred design, we have a shock absorber attached to the steering knuckle. Instead of the upper control arm, it is directly attached to the steering knuckle. Then we have steering knuckle, the spindle, and the lower part of the steering knuckle is attached to the lower control arm, and that is attached to your body or linkage. Then we have a bump stop. All the heavy vehicles or the load carrying vehicles have this assembly or this part, the bump stops. All suspension systems have a limit of travel up and down. They have some limit and it should not exceed those limits. To maintain those limits, we have some arrangement, and that arrangement sometimes is known as bump stop. If the vehicle hits a large bump in the road, the vehicle are forced upward towards the vehicle with a tremendous force. This force is absorbed by the spring of the suspension system, but if the bump is large enough, the suspension is compressed to its mechanical limit. So what will happen then? Instead of allowing the metal components of the suspension to hit the frame or body of the vehicle, a rubber or foam bumper is used to absorb and isolate the suspension from the frame or body. So basically it's a hard rubber or a foam rubber which is used to isolate and absorb the suspension from suspension jounce from frame or body. These bumpers are called bump stops. Suspension bumpers, strikeouts bumpers, or jounce bumpers. Jounce means jolts or to cause to bounce or move up and down. Once again, I read, all suspension systems have a limit of travel. They have a fixed limit of travel, mechanical limits. If we exceed those mechanical limits, then we have to have some certain arrangement, and that certain arrangement is known as the rubber bumps or foam bumps stopper. If the vehicle hits a large bumps in the road, the wheels are forced upward towards the vehicle with tremendous force. This force is absorbed by the spring of a suspension system. If the bump is large enough, the suspension is compressed to its mechanical limits. Instead of allowing the metal components of the suspension to hit the frame or body of a vehicle, a rubber or a foam bumper is used to absorb and isolate suspension from the frame or body. These bumpers are called bump stops, suspension bumpers, strikeout bumpers, or jounce bumpers. Jounce means jolts or to cause to bounce or move up and down. So it is the yellow portion which is we are saving. This is on the lower control arm and this is on the upper control arm, the suspension bumpers. And if we have a leaf spring, it is attached to the frame, this rubber portion, this is your suspension bumper. Suspension bumper are used on all suspension system to prevent metal to metal contact between the suspension and the frame or body of the vehicle when the suspension bottom outs over large bumps or dips in the road. So basically, after the mechanical limit is crossed, then these are the rubber bumpers or suspension bumpers, which stops the metal to metal contact of the suspension system with the frame or platform of the body. Now, the next is the short oblique long arm suspension system. The short oblique long arm suspension uses a short upper control arm and a longer lower control arm. and usually referred to as a SLA type suspension. The two main links in the short oblique long arm suspension system are the upper control arm and the lower control arm. So as the name suggests, the upper control arm is of shorter dimensions and the lower control arm is of the longer dimension. This type of suspension goes by the variety of names including unequal arm suspension, double wishbone suspension, or A-arm suspension. So we can say that this type of suspension goes by variety of names including unequal arm suspension, double wishbone suspension, or A-arm suspension. Unequal arms refer to the fact that the two arms are of different length. Upper and the lower control arms are of different length, while the double wishbone and A-arm derives from the shape of the arms, which are frequently triangle with one mounting point at the knuckle and two at the frame. When the SLA suspension uses a straight two-point lower control arm, there is almost always a strut rod that braces the lower control arm against the frame. The strut rod can attach to the frame at a point either forward or to the rear of the control arm. So let's see how it's look like. Now, the upper control arm is shorter than the lower control arm on a SLA suspension. We have this upper control arm, and then we have this lower control arm, and we have this spindle here. This is the pivot point and this is the frame. A typical SLA front suspension using coil spring, this green one is the lower control arm, the longer in dimension, and the upper green is the upper control arm, smaller in dimension. We are having a spring arrangement, we have a shock absorber arrangement, and it is attached to the frame and to the knuckle of the steering knuckle of the wheel. Now the solid axle type or the front suspension type. Early cars and truck used a solid or straight or front axle to support the front wheels like this. This is the solid I-beam type. Mostly early vehicle uses single straight axle, or we call it as I-frame or I-beam suspension, front suspension. A solid axle front suspension is a very strong and is still being used in manufacturing of medium and heavy trucks. The main disadvantage of solid axle design is its lack of ride quality. So the main disadvantage while you are using the solid axle design is lack of ride quality. When one wheel hits a bump or dip in the road, the force are transferred through the axle to the opposite wheel. Solid axles are currently used mostly at the rear of the vehicle. Previously, it was used in the front suspension system, but now it is used in the rear vehicles suspension system. Now, the another type is the double wishbone suspension system. The double wishbone suspension can also be referred to as double A arms through the arms themselves can be A-shaped or L-shaped. A single wishbone or A-arm can also be used in various other suspension types, such as variation of the MACPHERSON strut. The upper arm is usually shorter to induce negative camber. We will study these terminologies in when we will study the next chapter, the steering chapter. The upper arm is usually shorter to induce negative camber as the suspension jounce rises, and often this arrangement is titled as SLA or short long arm suspension. When the vehicle is in turn, body rolls results in positive camber gain on the lightly loaded inside wheels, while the heavily loaded outer wheels gain negative camber. So this wishbone upright painted in yellow for your. A double wishbone suspension is an independent suspension designed for automobile using two occasionally parallel wishbone shaped. These are the parallel wishbone shaped. To locate the wheel, each wishbone or arm has two mounting points on the chassis. This upper one has the two and lower one has the two. And one joint at the knuckle. So one joint at the knuckle. The shock absorber and the coil spring mount to the wishbone to control vertical movement. So this is the shock absorber and coil spring to control the vertical movement. Double wishbone design allows the engineers to carefully control the motion of the wheel through suspension travel, controlling such parameters as camber angle, caster angle, toe pattern, roll center, height, scrub radius, cuff, mechanical abrasion, and more. So this is how it works, your double wishbone suspension system. The A-frames is moving like this, or and spring and coil arrangement is inside. This is how it is look like in the figure. This you can see from his YouTube channel. Now, the advancement has been there. Now, previously we have studied the mechanical hydraulic suspension system. Now, what about the electronics? When we involve so much electronics in the vehicle, so we have the electronic suspension system. Since the mid-1980s, many vehicles manufacturers have been introducing models with electronic suspension controls that provides a variable shock stiffness or spring rates. So those provides variable shock stiffness or spring rates. The main advantage of electronic control is that the suspension can react to different conditions. The system provides a firm suspension feel for fast cornering and quick acceleration and braking with a soft ride of cruising. Conventional suspension system, electronically controlled suspension system. An electronically controlled suspension system can help reduce body roll and other reactions better than most conventional suspension system. So basically the sensors are giving input. So with the help of those sensors, the electronic control units of the suspension system is maintaining those forces in all the scenarios. So electronic suspension controls and sensors and switches provides input to the electronic control module or supercomputer. The electronic control module, which may also be referred to as the electronic control unit, is a smaller computer that receives input in the form of electrical signals from the sensors and switches and provides output electrical signals to the system actuators. So basically, as we have studied in the electronic ECU engine control unit or the electronic control unit, same, the input is coming from the sensors and from the electrical signals switches to the ECU signals amplifies and then giving the output to the actuators or the hydraulic systems to act accordingly. The electrical signal causes an actuator to perform some type of mechanical action. Let's see, we have this figure. Input device monitor conditions and provides information to the electronic control module, which processes the information and operates to the actuator to control the movement of the suspension. Sensors gathers information which are mounted with your wheels and the suspension system. That information goes to the electronic control unit, the ECM, which processes this information and then gives the response to the actuators, which responds to that signal. And the suspension system provides appropriate damping or spring rate in that condition. So this is how the electronic suspension control sensors works. So active suspension system will be working like this. So with this, we comes to the end of this sixth chapter of our automotive technology, that is the suspension of a vehicle. So I hope you are enjoying my videos and lectures. Do follow me. Thank you very much.